in this example, we're going to have a polar function, and we're going to have to find the area enclosed in that polar function on a certain region. We're actually going to have to figure out what that region is. So our goal here is to find the area of a region bounded by one petal of the graph of r equals 3 times sine of 3 theta. If we look at what this function is going to look like, it's going to be a 3-petaled rose, kind of like in our previous example. We want to find the area enclosed by one petal. So to find the area enclosed by one petal, the first thing we're going to have to do is figure out what theta values are going to be our starting and ending values. So if I go back, this graph here is going to kind of help us here. If we just look at this one over here, if we just look at this petal in the first quadrant, when theta equals 0, that's going to start drawing the petal. And when we get back to the end here, it's going to be about what? Remember, this is being multiplied by pi, so it's going to be about pi divided by 3, right? That 0.34, 0.33, that's about a third, right? So I would expect that this is going to be pi over 3 where it's going to end. So what we're going to do to figure this out is we're going to figure out where theta equals 0. To figure out where theta equals 0 here, what do we do? First of all, do you guys understand why we want to figure out where r equals 0? I'm saying that wrong.
Because that would be the origin?
Yeah, that would be the origin. So if we want to figure out what the area enclosed in one petal is, the point is going to be at the origin, at the beginning of the petal, and at the end of the petal. So we want to figure out where r equals 0 because that's going to tell us where those two endpoints are going to be. So if we want r to equal 0, what do we do? Set 3 sine of 3 theta equal to 0, right? And so if we divide by 3 on both sides, we have the sine of 3 theta equals 0. And when is sine equal to 0? It's equal to 0 at 0. It's also equal to 0 at pi, and 2 pi, and 3 pi, and 4 pi, and so on, right? So we know that sine of some angle is going to equal 0 when that angle is equal to n pi, right? You guys agree with that? So our angle is going to be 3 theta, so this is going to be 3 theta equals n pi. So I can plug in any value, any integer for n, and this is going to be a valid equation. This is going to be a solution to my equation. And so to solve for theta, I get theta equals n pi over 3. So remember, our starting value when r was equal 0 the first time was when n equals what?
0.
Yeah, so when n equals 0, that's going to be our starting value, so that's going to be alpha equals 0 there. And then our ending value is when it's going to equal 0 the next time, which is when n equals 1, which would be what? Pi thirds. So we're going to start at 0 and go to pi over 3 for theta. Now that we've got that, this is actually a lot simpler than finding the derivative. All we have to do is plug this into our formula. So it's going to be 1/2 times the integral from where to where? 0 to pi over 3. And then we're going to have the radius squared. So what is the radius squared here? 9 sine squared of 3 theta with respect to theta. Most of the time when we do this, I will ask you to use a calculator to evaluate this integral. This is not an integral that we would know how to evaluate because we have the sine squared there, and it gets a little tricky. You'd have to use a power reduction formula to do that, which you've seen those before. You should have last year at least. But go ahead and use your calculator to evaluate that. What do we end up getting for this area? 2.356, rounded to the nearest thousandth.